Our number one challenge problem is the integral of limits from pi over 8 to 0 sine raised to 4 8x cos sine raised to 3 4x dx. We all know that sine 8x is equals to 2 sine 4x cos 4x, right? So this, we will square this into 4. So to square this, the answer is 4 raised to sine raised to 4 8x. 2 raised to 4 is 16 sine raised to 4 4x cos sine raised to 4 4x. So that's it. This is now our new transformation. So we will copy this, the limits from pi over 8 to 0. Sine raised to 4 8x is equals to 16 sine raised to 4 4x cos sine raised to 4 4x. So 16 is constant. We will take the constant out. We will write here outside our integral. So sine raised to 4 8x is sine 4 raised to 4 4x cos sine raised to 4 4x times our cos raised to 3 4x, and do not forget the dx. We can combine these two cosine. So to combine this, we will just copy this again. Sine raised to 4 4x. We'll just simply add the exponents. 4 plus 3 is just 7. Cos raised to 7 and 4x dx. To here, we will simply use the u substitution. Our u is 4x. Our du is the derivative of 4x, which is 4 dx. We are lacking of 4, so we will add 4 here and also 4 here. And then we will now compute our new upper and lower limit. So 4, which is our upper limit, is pi all over 8. 4 times pi all over 8 is equals pi over 2. Our lower limit is 4 times 0, which is our lower limit here is 0, is equals to 0. So that's it. We already have our new limits and our new formula. Write our constant, which is 16 all over 4. Our new upper and lower limit, which is pi all over 2 and 0. Our sine raised to 4. We'll just use our u, since u is 4x, u, and cos raised to 7 u du. So we will now use the Wallace formula. 4 minus 1 is 3. 3 minus 2 is 1. 7 minus 1 is 6. 6 minus 2 is 4. 4 minus 2 is 2. That's it. We will end here since our endpoint is 2. All over the sum of our two exponents, which is 7 plus 4 is 11, times 11 minus 2 is 9. 9 minus 2 is 7. 7 minus 2 is 5. 5 minus 2 is 3. 3 minus 2 is 1. We'll end there. And then we will multiply it to 1 since our two exponents are not both even. And then we will just cancel the common. This is 4, 3, and then 1. And then our final answer is 64 all over 1155. That's it. Our problem is solved and challenge problem number 1. Our challenge number 2 is the integral of limits from e, which is Euler's to Euler's to 1 dx all over x ln x times ln of ln x. First is we will use the u substitution, which is our u is ln x, the derivative of ln x is equals to 1 all over x. From this, we will get our new upper limit and our lower limit. We will just simply substitute the e to our ln x, which is ln e is equals to 1. Our new lower limit is ln 1 is just 0. So this is our new formula, which is equals the integral of limits from 1 to 0, 1 all over u ln u du. From here, we will use the integration parts. Integration by parts, which has the formula of the integration of u v prime equals u v minus the integral of u prime v. We will get ru, which is the 1 all over u ln u, and the integral of this is ln u plus 1 all over u squared ln squared u. Our v here is u, and our v prime is 1. And then we will follow the formula, which is uv minus the integral of u prime v. We'll just simply copy, which is 1 all over u ln u minus the integral of ln u plus 1 all over u squared ln squared u du, limits from 1 to 0. We'll just copy the first term and we will simplify the second term, which is the ln u plus 1 all over u ln squared u du, limits from 1 to 0. From here, we will expand this, and it is the 1 all over u ln u plus 1 all over u ln squared u. In here, we will use the sum rule, which we will integrate the both term. So our answer is, and our answer in these two, and we will copy our first term, which is this. Our answer is 1 all over ln u minus ln of ln u minus 1 all over ln u, limits from 1 to 0. We will simplify this, and it is equals to ln of ln u, limits from 1 to 0. So our final answer is this, ln of ln 1 minus ln of ln 0. I just copied like this since if we will compute it to our calculator, it will be undefined. That's all.